Hi everyone. So today we are going to take one more question from ACT previous year papers. It says in this domain, negative pi over 2 to pi over 2, the absolute value of sine theta is greater than or equals to 1. So you see the curve of y equals sine of theta. It somehow looks like this, right? It starts from 0 and goes on. So this one is the pi over 2. And this point is the negative pi over 2, right? That's how it looks like. And if they're trying to find out the absolute value of sine theta, so if we take the absolute value of sine theta, which means all the negative values of sine theta will become positive. So this negative portion will be shifted to upward, right? Like this. This negative portion will be shifting upward. So you will get a curve like this. And this portion as well will be shifting upward. Now it says that absolute value of sine theta is greater than or equals to 1. They're saying greater than or equals to 1, but we know that absolute value of sine theta cannot be more than 1, right? Sine theta can be like the maximum value of sine theta can be 1, and the minimum value of sine theta can be -1. We can see from this graph, right? That's the maximum point plus 1. This one is the minimum point, -1. And if we take the absolute value of them, which gives you +1, absolute value of this, which gives you +1. So absolute value of sine theta cannot be more than 1. So it can be equals to 1, right? So absolute value of sine theta, it says, can be greater than 1 or sine theta can be equals to 1. This cannot be true, right? Because absolute value of sine theta cannot be more than 1. So we have one option left, which is absolute value of sine of theta is 1. So when it's possible, you see, the domain is restricted. It's from negative pi over 2 to pi over 2. So from negative pi over 2, from this to pi over 2, including negative pi over 2 and pi over 2. So what are the x values for which the absolute value of sine theta becomes 1? We can see there is one point at negative pi over 2. So when you plug in x equals negative pi over 2, right? There the value of sine theta is +1, right? So one value is negative pi over 2. And in this curve, you see there it goes to 1, +1, then 0, then again goes to +1. So the next +1 value you'll get at pi over 2, right? See, at x equals pi over 2, you'll get the sine theta value as 1, right? So in this negative pi over 2 to pi over 2, in this region, we are getting just 2 times absolute value of sine theta is 1. First point at negative pi over 2 and at pi over 2. And rest of the portion of the curve are below +1. So it's lesser than 1, right? So only two options are possible. X value can be negative pi over 2 or x value can be pi over 2. So you can write x values are, first one is negative pi over 2 and next value can be positive pi over 2. So this option A. Okay, this one is the graphical approach, but you can solve it by using the inequality concept, the compound inequality. So whenever, let me erase this. Whenever you have absolute value of something, sine theta here given, greater than 1. So you can write it in this way, right? Either sine theta is greater than equals to 1 or sine of theta is lesser than or equals to -1. It says sine theta equals greater than or equals to 1, but sine theta cannot be greater than 1. So it's just sine theta equals to 1, right? And in this case, sine theta is lesser than or equals to -1, but sine theta cannot be less than -1. So only possibility, sine theta can be equals to -1. So when sine theta is 1, then theta equals pi over 2. And many more things. It can be 5 pi over 2 and 9 pi over 2, but we are restricted, like the domain is restricted basically from -pi over 2 to pi over 2. So in this domain, only value of theta possible, it's pi over 2, right? And when sine theta equals to -1, in this domain, we know it's only at -pi over 2, right? At -pi over 2, the sine theta becomes -1. So you have two values of theta. First one is pi over 2, and second one is -pi over 2. So that's it. So option